this experiment is about components of a force. What we're going to do is try and find the unknown weight in the middle by using the idea of forces. Okay, we have two weights that we know about at the side here. When we change them, it will lift this up. Okay, if they're the same, it will go into the middle. If they are different sizes, then it will pull it in different directions. So we're going to use the idea of trigonometry to calculate this unknown weight. Now, both of these strings that are diagonal here, they're going to be pulling that upwards. That's the tension that's going to lift that up. Now, this diagonal string is going to pull it sideways. It's also going to pull it upwards. So this is lifting in two dimensions, two components, horizontal and the vertical. This one is doing the same, horizontally the other way and vertically. Now, if we get this into equilibrium, so it's stationary, then both these forces are pulling the same sideways. So we don't need to worry about that, but they're each lifting it up. And if we find out how much each string is lifting up, then we know how much in total it's lifting up. So, if I add on some weight onto each side, then it will balance. At the beginning there, it was sat on the ground, so actually there was a hidden force, and that's the force of the ground pushing upwards. But now this is in equilibrium, so horizontally we end up with a resultant force. They add up to 0. Upwards, they're both lifting the same amount. So I have 400 grams here. We can find the weight by multiplying that by G, 9.81. 400 grams here, so same value. And what we need is we need to know how much is pulling up and how much sideways. So we need to measure the angle. So I'm going to use my large protractor. The idea is nice and simple. I could measure from the vertical. I could measure that angle. Or, if you prefer sines, you could measure from the horizontal. But actually, if I measure between the two strings, so if I take that angle there and I measure all the way around, because these are the same, this angle will be symmetrical. So if I measure from here round to here and then half that value, then what I'll get is a value that is actually twice as precise. Okay, the measurement uncertainty, the measurement give or take within it will be halved because I'm going to half the angle. Okay, so through this video I'm going to set a load of close-up pictures, and all of them are for the same weight. So you're going to need to find the angle from the vertical to one side. You're then going to find, because you have that weight there, you're going to find a vertical force, and because there's two of them, you double it. If you repeat it for the different angles, because of different weights, I'm going to keep adding more and more and more, and it will make that angle larger and larger at the top. If you do that, you should of course get the same weight because it's the same metal in the middle, and because of that you can get average of the results. Okay, give it a go, write it up and show the calculations nice and clearly in your books.